Hello everyone, myself Professor Tushar Gujarati from SND College of Engineering and Research Center Yeola. Today we'll discuss one topic based on mechatronics subject. The topic name is Introduction to PLC. So we are going to study here Introduction of PLC. PLC means what? Programmable Logic Controller, which controls many activities, many actions, many processes in industry. So let's start with this introduction. So a programmable logic controller, that is PLC or programmable controller, is a digital computer used for automation of electromechanical processes in modern factory automation. So in this modern era, now we see all the processes are fully automated in factories. Okay, so this automation is done with the help of PLC, which uses one digital computer used for automation of these electromechanical processes. So for example, you can see the control of machinery on factory assembly lines. So you check, there is many machineries are available on factory assembly lines. So these machineries are controlled with the help of PLCs, as well as heating, ventilation, air conditioning processes are also controlled with the help of PLCs. Plastic injection molding machines are also controlled. Some commercial washing machines are also automated with the help of PLCs. You can check in your house, there is automated washing machine is there, which is fully automated with the help of PLC. Okay, so like this many examples are there of PLC. So PLC consists of input and output devices. Okay, so suppose you want to control any process or machine with the help of PLC. So PLC will require field inputs and field outputs. Okay, so the field inputs are taken from some measurements with the help of sensors, transducers, and these inputs are given to PLC, and PLC will take some control actions with the help of field outputs. Okay, and it will control the process or machine. So the PLCs are members of the computer family using integrated circuits instead of electromechanical devices to implement control functions. So here PLC are member of computer family. Okay, they are one of type of computers and they uses integrated circuits, ICs. Okay, and they are capable of storing instructions. They store instructions such as sequencing, timing, counting, arithmetic, data manipulation and communication to control industrial machines and processes. So if we want to control industrial machines and processes, we need all these type of operations: sequencing, timing, counting, manipulation. Okay, so all these are done with the help of PLCs. So why we use PLC? Okay, why there is need of PLC? So first, it's hardwired panels or relay logic are very time consuming to implement due to wiring and debugging related issues. So in the initial stages, the hardwired panels or relay logic was used. Okay, with the help of wiring, we have to do all the wiring for controlling or doing any automation of the plant. So which was very time consuming process. Okay, and there were some debugging issues also present. Okay, so it was very time consuming. Also, because of these all issues, there is need of another controller which can do faster and operates in real time. Okay, which is faster and operates in real time, which can withstand vibrations, temperatures, humidity and noise. Has inbuilt interfacing for input and output. There is interfacing which is flexible and adaptable, to easy to program and reprogram. It should be adaptable to programming and reprogramming, easy to troubleshoot and maintain. Okay, and it consumes less space, require less wiring, comparatively cheaper. Okay, so these are all the needs of PLC and which is fulfilling by PLC. PLC is fulfilling all these requirements. That's why we are using now PLC. Okay, so for particular application or for a particular process or for particular PLC, there is some selection criteria is there. So first criteria is application requirement. Okay, so application requirements means what, for which application we are using PLC. Okay, that we have to decide, and then we have to select proper PLC. Then input output requirement. So you are using particular PLC, how many inputs you can connect, how many outputs you can connect. So that is also important. Memory requirement, the PLC you are using, what is the memory of that PLC, how much programs it can store. Okay. CPU requirement, which type of processor you are using for controlling all the things. Software requirement and operator interface, which kind of software you are using for PLC, what is operator interface, how operator is going to install the program. Communication requirement, how you are communicating all the devices with the help of PLC. Environmental requirements, is there any issue of environment on the PLC working. Okay, so all these criteria are very important while selecting PLC. So for PLC we need input output devices. So input devices provides inputs to the control system. In case of discrete state process control, the inputs are two state specifications such as limit switches. Okay, so limit switches are used, the switches may be open or closed. Comparators are used, which can show high or low. So these are input devices which provides inputs to the control system. Our PLC is one control system which require inputs. So inputs can be taken from switches, comparators, or you can use push buttons also. They may be depressed or not depressed. So these are, every input device has two positions, open or close, high or low, or depressed or not depressed. Okay. And the output devices accept outputs from the control system. Okay. So control system gives outputs. In discrete state process control, the outputs accept only two state commands such as lights either on or off. Okay, these are two states, on or off. Motors rotating or not rotating. Okay, solenoids engaged or not engaged. So like this there are conditions, on or off, plus or minus, rotating or not rotating, engaged or not engaged. Okay, so some symbols are used for input devices and output devices. So these are some input devices. So first they have shown PB1, that is push button 1. So monetary action push buttons, those are called as monetary action push buttons. The symbol is shown like this. So you have to press that push button, press or depress. So first case is normally open and second case is normally closed. There are two cases, normally open and normally closed. So second switch is physical limit switch. The symbol is shown like this, and it is denoted by LS1, LS2. Okay, so they are also normally open and normally closed. Third switch is pressure limit switch. You can see the symbol of pressure limit switch. Okay, third limit switch is pressure limit switch. Fourth one is temperature limit switch, and fifth one is level limit switch. So every switch has different symbol. Okay, and all the switches are open and closed form, normally open and normally closed. Okay, now these are output devices. So output device, first is motor. So there is one circle and inside that M1 is written. Second one is solenoid. Solenoid symbol is something like this. And third one is light. Inside the circle we have to write down which color light is there, red, blue, black. So we have to write with the help of R, it's red. Okay, so like this input and output devices are used. So we'll see now use of relay controllers and ladder diagram. Okay, so use of monetary push button switches and a relay to implement the latch. So this is one ladder diagram program over here we have shown. So PLCs have programming in the form of ladder diagram. Okay, you remember this ladder diagram programming is there, and also sometimes we have to use relays in the ladder diagram. Okay, so ladder means what? There are two vertical lines are there and some horizontal lines in between them. So ladder is usually denoted like this. Okay, this is called as ladder, and same type of programming is done in the ladder PLCs. Okay, these horizontal lines are called as rung. Okay, so these are rung 1, rung 2, rung 3. So horizontal lines are called as rungs and vertical lines are called as supply lines. So here supply is given plus minus, so these are called as supply lines. So in this diagram you can see push button is used in the first rung. So this is our first rung. So what is used here? Push button 1 is used, which is normally open. Then push button 2 is used, which is normally closed. This is CR1. CR1 is nothing but relay coil. Okay. So relay coil CR1. So related to this relay coil, there are contacts are there. So this is first contact, relay contact 1. This is also contact related to relay coil. This is CR1 and this is CR1. We can take contacts either normally open, normally closed. Okay. And we have used lights here, green light, red light. Okay. So like this ladder diagram is shown over here. And this is a related circuit diagram for this ladder diagram. Okay. So like this circuit diagram is used, or wire diagram is used for such a PLC or such a example. Okay. So I will just show you one example. So when you press this push button, okay, what will happen? The supply will go something like this. Okay. And this coil will get energized, CR1, and because of this contact will get closed, CR1. Okay. And the supply will go something like this. Okay. This is called as latching. This concept is called as latching. And because of this this normally closed contact will get open, and this normally open contact will get closed. Okay. What will happen here? This will get open and this will get closed, and because of this red light will be on and green light will be off. Okay. This will be off and this will be on, red light, because this is closed here. Supply will go something like this and red light will get on. So this is one simple example I have shown here. We'll study this in later videos. Okay. So now we'll see relay sequencers. Before the invention of PLC, control, sequencing and safety was done with the help of interlock logic for manufacturing automobiles was mainly composed of relays, cam timers and dedicated closed loop controls. Okay. Before invention of PLC, what was used? Relays were used, cam timers were used and dedicated closed loop controllers were used for controlling all the processes. One way to provide discrete state controller is to use physical relays to put together a circuit that satisfies requirements of the ladder diagram. So one way to provide discrete state controller is to use physical relays. We are using physical relays to put together a circuit that satisfies the requirements of ladder diagram. Okay. When a program has been wired into relays that make up the relay logic panel, it has been programmed to meet the ladder diagram. Okay. So wiring was used with the help of relays to make the relay logic panel, and then we meet the ladder diagram. So like this relay sequencer were used previously. If the event sequence is to be changed, if we want to change the sequence, it is necessary to rewire all or part of the panel. So we need to rewiring of all the parts. It may even be necessary to add more relays to the system or to use more relays than the previous program. So all these problems were faced before invention of PLC. Okay. Before invention of PLC, we were using cam timers, closed loop controllers, relays. Okay. And wiring was done in between them, and it was very difficult to change the wiring or add extra part in between them. Okay. The move from relay logic controllers to computer based controllers was an obvious one because, okay, so all these problems were overcome in the PLC. The input output variables of discrete state control systems are binary, just as with computer. So computer has binary input output, which was very easy. Second point, many of the control relays of the ladder diagram can be replaced by software, which means less hardware control. So hardware was replaced by software. It is easy to make changes in program sequence of events when it is only of change of software. So programming sequence was also very easy because of software. We can change any program, modify program. Okay. And special functions such as time delay actions and counters are easy to produce in software. So time delay action and counters were easy to adopt in the softwares. Okay. So because of all these advantages, computer based controllers or PLCs was used. Okay. So again we'll repeat. The first was input output variables were binary in nature, which was easy. Second one, software was replaced by hardware. sorry, hardware was replaced by software. Third point is program sequence can be easily changed, and next point is timer and counters were easy to adopt. Okay, because of this, PLC is very important.